So you guys were already introduced to one of the forms of a quadratic, and you guys already know how to work with it. So we'll start off with that one. It's called general form. Or you can call it standard form. Either one works for me. I tend to call it standard form. So in the book they call it general form. If you ever see general form, what they mean is standard form. Somebody remind me what the standard form of a quadratic is?
X squared.
F of x.
F of x, then ax squared plus bx of x.
Bx plus c, right? One small thing that we need to remember, a cannot equal to 0. If a equals 0, then it's not a quadratic.
What is it? Is it like a...
It would be linear.
Oh.
So, what do we know from this? What stuff do we already know from this? Do we know what the y-intercept would be?
C.
So we already have information from this, right? We already know that the y-intercept is going to be c, but how do I write my y-intercept?
0 and then something. Like C.
0, comma c. What else can I find from this? I want to hear more than just Jonathan. Because then all you're going to hear when you watch the video is Jonathan's voice. That'd be bad. Just kidding, Jonathan. Yeah, it's the line of symmetry, but before we get the line of symmetry, we have to get the what? Because we can't get the line of symmetry just from my standard form. But we have to get the what?
X chord.
The x chord of the what, though?
The vertex.
The vertex. So we know how to get the vertex from here. How do I get the vertex of this thing? Negative b over 2a. That's the x chord, right? And then the y chord is, like you said, f of negative b over 2a. So yes, that's how you find the vertex. Now you guys talked about the axis of symmetry. How would I find the axis of symmetry? What is it? Yeah, but like if this was the axis of symmetry, what would x be equal to?
Oh, the x of the negative b to 2a, right?
Negative b over 2a. Do we know anything else from this? We know one more thing. One more thing for sure that I showed you guys. Starts with a C. Ends in concavity.
Ends in what?
Concavity. And it starts with a C. Wow. That's prime stuff. That's like good joke stuff. That's dad joke stuff, and you guys are just falling asleep. What is it? There you go. You can do it, Jonathan. What is it?
Is it cavity?
Not cavity, dude. It starts with a C and it ends in concavity. What is it? Come on, guys, just read it for me, please. It's concavity. And what does concavity mean? Did you say that? You whispered it. You can watch the video. You can't hear it. You can't hear it. Uh-huh. What does concavity mean? What does concavity tell you? Oof.
The curve of the line.
It's something with the curve.
Up and down.
Yeah, it tells you whether it opens up or opens down. So concavity,
Why did you say up and down?
because if I just said up and down, you have no idea what I'm talking about. It opens,
I can remember that way. I'm remembering up and down.
it opens up or opens what? It's concavity, not opens up and down. Okay, so when does it open up? So if a is greater than 0, it opens up. And it opens down if a is what? A is less than 0, negative. Yeah. So see, even though we're learning this now, you already have a bunch of information from this, don't you?
Yeah.
Okay, so that's good. Is there anything on this part that you guys need me to kind of go over? Well, what part of this was the hardest? I'm pretty sure I already know, but what part of this was the hardest for you guys? Graphing, but what part? Like, if you had the points, you can graph them, right?
Oh,
But finding the points was hard. What part was the hardest? vertex, right? So the downside to this form is that when you're finding the vertex, it's kind of difficult. I agree with you guys. When you have standard form and you have to find the vertex, it's not the easiest thing to do. There's quite a bit of work to it, right? So there's other people that also agreed with you, and they wrote another form, and it's called vertex form. Some of you guys already know vertex form?
Yeah, I got a 90 on the.
Vertex form is a lot better. It's, in my opinion, I prefer vertex form. Okay? And vertex form is the following. F of x. What is vertex form if you remember it? He forgot. He got a 90, but he forgot.
I mean, yeah.
It was a while ago, I get you. A x minus h squared plus k. Okay, let me rewrite that again. That looks ugly. Sorry. This is completely different than standard form, but it tells us the same information. Okay? The only thing is, with vertex form, it's very easy to find your vertex. That's why it's called vertex form. Your vertex is just going to be whatever h and k are. That's it. No plugging anything in. It's just h and k. That's vertex. That's your vertex. You can still find concavity. If a is greater than 0, it opens up. If a is less than 0, it opens down. Unfortunately, that's the only thing you can find with vertex form. Your vertex and which way it opens. So which one gives you more information? The quadratic, right? And I'm sorry. You can find one more thing. Whenever you have your vertex, automatically by having your vertex, you then have the what? Axis of symmetry. Very good. So you can also have your axis of symmetry. And the axis of symmetry is going to be whatever h equals. Okay? So what's the one thing that you don't have from standard form? What does standard form have that vertex doesn't? What is it? It doesn't have the y-intercept, right? So it does not have the y-intercept. So if you wanted to find your y-intercept, you can, but vertex doesn't automatically give you the y-intercept, whereas standard form does. So far, so good? Okay. And then the last one, the last form that we have, it's called factored form. And factored form, it's pretty good. It's not bad. F of x equals a x minus r1 times x minus r2. What factored form gives you is, just like the other ones, it also gives you concavity. So if a is greater than 0, it opens up. If a is less than 0, it opens down. No vertex though. So you cannot get the vertex from this. But what it does give you is it gives you the roots, also known as your zeros. Is there an E on zeros? Who's the English people? There's no E, right? So just like that. That's what I thought. Gives you your zeros, also known as your x-intercepts. Okay, so it gives you those. And your zeros are going to be R1. Your first 0 is going to be R1, comma 0. And your second 0 is going to be R2, comma 0. And that's the only thing those give you. Now we're gonna graph a couple of these so you guys can see the difference between them. Why one is better? Why some is? Honestly, guys, it depends on what type of problem you're doing. It depends on what the question is asking you. If somebody's asking you, what's the x-intercept, which form would be best? Factored form. If they're asking you, hey, graph this, what form would be best? I personally like vertex. If somebody asks you, hey, give me like a more, if it's just an easy general graph where you don't have to be a specific, vertex form works. If you have to be very specific, then I probably want to go to standard form. Okay, so we're going to graph one equation, just one equation, but we're going to use the same thing for all of them. Okay, or different methods for each one. What's up? A ruler, yeah. Does anybody else need a ruler? If you need one, there's some up here. Here you go. Well, you know what? Before we do that, all I want you to do is to classify them. So classify the following, or categorize. So classify them as standard, vertex, or factored. So we'll go with f of x equals -2, x plus 1, x plus 4. G of x equals -1/3 x squared minus 3x minus 6. H of x equals 2 x plus 1 squared plus 1. What's the first one, guys? First one would be what? That would be factored. What about the next one? That would be standard. And what about the last one? That would be vertex. Everybody okay with those so far? Alright, we're going to graph these right now. Okay? So we're going to start off with the first one, which is graphene factored. If I'm going too fast, please let me know. Too fast? Alright. I'll write it down. I'll give you guys time. Everybody good? Jonathan, you good? Was that a yes?
Yeah.
Uh-huh. All right. So I know you're new to this, but on the, let's see, I'll graph it over here, and on the right side, I'll put all the information that I know from this thing. What information can I take from this? Can I get a vertex from here? What do you think, Nicole? Can I get a vertex from this? I can't get a vertex. What can I get from this, Nicole?
The symmetry?
No, hold up. Let's let Nicole finish this one.
Oh, my bad, Nicole.
What is it? Not the y-intercept. No, this is factored form. So if you took the notes, it showed you what you can get from factored form. So what can we get from factored form? If you didn't take the notes, check on somebody who did and see what they can get from factored form. What is it?
Intercept, huh?
She's right. What is it? Yeah, you can get the x-intercepts. So we can get our x-intercepts. So the x-intercepts, guys, it's where your line's going to cross. It's where your, here, I'll put it in, I'll highlight it. It's where our parabola is going to cross our y-axis. So that's what our x-intercepts are going to tell us. Okay, so my first x-intercept, remember, to find the x-intercepts, your factored form is f of x equals a x minus r1 x minus r2, and the function that we have is f of x equals a, sorry, not a, f of x equals negative 2 x plus 1 x plus 4. So what is our first r, guys? So let's look at it this way. What's our first root? What's root 1? It's, what is it? A lot of you guys are going to think it's positive 1, but look, on the root 1, do you see how it's negative over here? This is the only thing that gets tricky when we're trying to find roots. If you can get this down, everything else is easy. You see how this says negative 1? Or negative r1? You take the opposite sign. So even though this is a positive 1, my root is actually going to be what? Negative 1. So my first root is negative 1. So root 1 is negative 1, but you write it the way, you write it like this. Over negative 1, up 0. So that's root 1. Root 2 is going to be what, guys? Root 2, and you write it as over 4, up 0. I'm sorry, negative 4. So let's draw these out. So this is negative 1, negative 2, negative 3, negative 4. So I have both of my roots. So I have 2 points on my graph. And what's the last thing that this is going to give me? It's not going to give me my vertex, but it will give me what? Concavity. So it will give me concavity. What is A, guys? A is negative 2. So that means A is less than 0. So that means it opens what? It opens down, right? This is going to open down. Since it opens down, it's going to do this. And that's how you graph using factored form. Notice, what do I still not know? My vertex is basically a mystery at this point, right? There's ways to find it. We're going to go over that eventually. But for now, we don't know what our vertex is. Do we know what our y-intercept is? It's a mystery from now, right? So factored form only gives you which way it opens up and where it crosses your y-intercept. Or your x-axis, your x-intercepts. Does that make sense? Do you guys want to try one of these, or should we move on to another one? Try one? Go ahead and graph that for me, please. I was still taking some. Trouble with this? Trouble with this? Yes. No. Yeah, I got you. Is that okay? So what would my roots be for this one? 1 and 4, right? And which way is it going to open? It's going to open up. So we can actually, I'll graph it on this one. So I'm going to go over 1 right here, 2, 3, 4, and then it's just going to open up like that. So you should have a graph like something. And I'll walk around one more time before we get started. Stop me if you have trouble with something. What's up? If you positive, if it's already negative, you hit opposite. This is probably the easiest form to graph from, but unfortunately it's not very accurate, because I don't know if the vertex is here or way up here. It's just a guess. So it's a quick way to graph something, but it's, again, not very accurate. All right, guys, what are my roots? What's my first root? 1, right? So I'm going to go over 1. So there's my first root. And what's my second root? 2, 3, 4. 4, 0. Is everybody okay with that? Okay. So from here I got 1, 0. And from there I got 4, 0. So those are my roots. It's going to open up or down. If it opens up, then that means my vertex has to be above the x-intercept or below. Where's my vertex going to be found? Below it, right? Now I have no idea where it is, so I'm just going to take a guess. And there's your graph. What is it?
Why are we going down again? Why are we going that way?
Why is the vertex going down?
Yeah.
Because the graph opens up. So since it's all on that concavity. So since a equals 2, a is greater than 0, so it opens up. And the only way for it to open up is if it has a vertex below it. Sound good, guys? Yeah? Okay, are we okay with this one? Yeah? Okay, now we're going to go to vertex form, which gives us a little more information. I got you. Here, I'll put some more information on this. This is my first root over 1 up 0. This is my second root over 4 up 0.
Alright, good.
You still writing? All right. Now we're going to be graphing from vertex form. What was our first equation that we worked with? F of x equals 2 to the power of x plus 1 plus 1. All right, so just follow along for this one, okay? Just please follow along. First thing I'm going to do is, since this is vertex form, I can extract the following information. I can find the vertex, and I can find concavity. My vertex is going to be whatever h and k are, and concavity is going to be whether a is whatever a is. So I'll just put it as a equal to whatever. Okay. So first, to find the vertex, I'm gonna do that over here. My general form is f of x equals a parentheses x minus h squared plus k. The function that we have is f of x equals 2 parentheses x plus 1 squared plus 1. Now this is the main mistake that I see people do when they're trying to find h. What do you guys think h is going to be? Will it be positive 1 or negative 1?
Negative.
It'll be negative. Why do you guys think it's negative?
Because positive and a negative is a negative.
Yeah, it says x minus, right? So you'll take the opposite sign. So for my vertex, h will be negative 1. What about k?
1.
Positive or negative?
Positive.
That one's going to be positive because it's already a positive k. So you take whatever sign is there. So right off the bat, I already know what my vertex is. Now as far as concavity, what does a equal?
2.
A equals 2, which means this opens what?
Upwards.
This opens up. So that's all the information I got from this. So if I were to graph this, I go over negative 1 and up 1. And this is going to open which way, guys? Up. So I know it's going to do something like that. The only other thing I know is my what? What's this red line represent?
Symmetry.
Axis of symmetry, right? Which is going to help me. I can use my axis of symmetry to make this more accurate. But again, vertex form and factored form, are they very accurate? Not very accurate, right? Okay, but they're very simple to graph with. Not as accurate, but a lot more simple to graph. Yeah. Which one do you guys prefer?
Symmetry.
Symmetry is not one of them. Vertex form?
Yeah.
Alisa?
Wouldn't be able to use the factored form with this type of equation because there's no x.
You can turn this into factored form. It's a process to do it. And we're going to get there. I'm going to have you guys go from one form to another. That's what we're going to get to eventually. But for now, I just want you to be comfortable with the forms. But yes, there's one way to get from one form to another. Everybody okay so far? Okay, let's try one on. No? Alright, let's try another one, guys. Don't worry, I'll scroll back up. Let me just at least write this. Give you guys about 2 minutes, 3 minutes to do that one. All you gotta do is get your vertex. That's the hardest thing here. Get the vertex and which way it opens up. Which way? F of x equals 2 parentheses x plus 1 squared.
Yeah, but
You guys went over this stuff last week?
Oh, we didn't graph it though.
You didn't graph it? No. But you guys were just finding vertex and stuff? How many of you guys have ever played Battleship? That's it? Nobody else has played Battleship? Well, we playing Battleship in this class.
In my class, yeah, we played it in the school year.
Oh yeah?
Yeah.
yeah, I was just like that.
It was math. It was dumb.
Yeah,
I got
same.
cheated, but
We're gonna be using math too.
No, that was it there.
it came like
The battleship?
teeth asking me what I had.
Bruh.
Can I scroll up now?
Of course.
What's my vertex, guys? Vertex is 2, 1. Very good. So I go over 2. 1, 2. And up 1. Which way does this open up? It opens down, right? So then my graph is going to look something like this. Now there's ways to make this a little more accurate. Like I said, just get used to this for now. Okay? We'll get into those particulars a little more. So concavity is A is -1, so it opens down. Any questions on this so far? Are we good? Yeah? All right, cool. So I want you to open up your Chromebooks.